QR decomposition using the Gram-Schmidt method is a technique in linear algebra that factors a given matrix into product of true matrices, an orthonormal matrix Q and an upper triangular matrix R such that A equals QR. The process begins by taking the column vectors of matrix A and applying Gram-Schmidt orthogonalization to produce a set of orthonormal vectors. This is achieved by subtracting from each vector its projection onto the previously obtained orthonormal vectors, ensuring that each new vector is orthogonal to the ones before it. The resulting orthogonal vectors are then normalized to form the columns of matrix Q. The elements of matrix R are calculated as inner products of these orthonormal vectors with the original column vectors of matrix A, which naturally results in an upper triangular matrix. This method is widely used in numerical linear algebra for solving system of linear equations, performing least square approximation and improving computational stability. Here are the step-by-step explanation of your QR decomposition program using Gram-Schmidt method in Python. Function definition. Def QR decomposition of A defines a function named QR decomposition that takes matrix A as numpy array as input. Matrix dimension and initialization. N, M equal to A dot shape, Q equal to NP dot zeros, N, M, R equal to NP dot zeros, M, M. N and M gets the number of rows and columns of matrix A. Q is initialized as 0 matrix of shape N, N to store orthonormal vectors. R is a 0 matrix of shape M, M to store the upper triangular matrix. Outer loop over columns for A in range M, V equal to A colon comma I dot copy. This loop goes through each column I of matrix A. B is initialized as copy of I column of A. This is modified to make it orthogonal. Inner loop of orthogonalization for J in range I, R J comma I equal to NP dot Q colon comma J comma A colon comma I, V equal to V minus R J comma I into Q colon comma J. For each previous orthogonal vector Q, the projection of A onto Q is computed using the dot product. This projection is subtracted from V to make it orthogonal to all previous vectors. Normalization and assigning to Q. After orthogonalization, V, it is a length norm is computed. If the norm is not 0, V is normalized, converted to a unit vector and stored in Q. This ensures that all columns in Q are orthonormal. Printing the results. Once all columns are processed, the resulting Q and R matrices are printed. User input and function calls. A equal to np.array eval input enter matrix. The program asks the user to input a matrix in Python list format. Eval evaluates the string input as a Python list. np.array converts the list into numpy array. The matrix is passed to the QR decomposition function. Hence, this is the output for the Python program. Thank you.